Hey everyone, we're going to get started with chapter 5, which is going to function on functional groups. Functional groups are a very important factor for this class. They are specific substituents, specific groups within a whole molecule that are generally responsible for characteristic chemical reactions in these molecules. So again, these are special groups that we see them react the same way over and over again. And generally, I'm going to cover most all of these functional groups throughout the class and how they react. So remember that the basic outline for an organic molecule is generally an alkane. We've already talked about alkanes. Those are hydrocarbons that are single bonded, right? That could be an alkane. An alkane can also exist as a ring, right? A cyclopropane is an alkane. Generally, these are not considered functional groups. They're just kind of like the skeleton, the scaffold for the molecules, and we'll be talking about groups that then are on those alkanes as functional groups. Things that can be thought as functional groups are things like double bonds or even triple bonds. Alkanes are not, but alkenes, which are double bonds, and alkynes, which are triple bonds, can be considered functional groups. Also, in the ring section, special six-membered rings consisting of sp2 hybridized. These are usually associated with double bonds. In arenes, we talked briefly about arenes in a previous chapter. These are considered functional groups. So the main example that you will see over and over is benzene, which is this six-membered ring with alternating double bonds. Okay, so this can be considered a functional group, and it's because it has reactivity. There's about 14 functional groups that are key in this class, and about another 8 that will kind of make appearance from time to time. You'll see some others as well, but this is just kind of the selection of the most common. So the most common functional groups you'll encounter are shown here. Remember that I'm just listing alkane to remind you what it looks like, but it's not usually considered an actual functional group. An alkane is the single bonds. Alkene is a double bonded hydrocarbon. Alkyne, triple bonded hydrocarbon. A benzene ring, sometimes called a phenyl ring. An amine, this is a nitrogen, and it can have hydrogens on it, or it could have other carbons on it. So something like this is an amine, and the squiggly line next to it means that it's just connected to an alkane chain in some way. An alcohol is an OH group. An ether is an oxygen that is sandwiched between carbons. So if you see a chain with an oxygen in between, that is an ether group. Alkyl halides, these are any type of halide, which are from the halogen group on the periodic table. So this includes fluorine, chlorine, bromine, iodine, all of these. If they are just added on as a group, they're an alkyl halide. A thiol, thiols are similar to alcohols, except they are an SH group. Now here, these ones at the bottom are the ones I think people have the most trouble with. So really try to be able to differentiate between these groups on the bottom. All of these groups can be subclassed into something called a carbonyl. A carbonyl just means a group where there is a carbon double bonded to an oxygen. And what is bonded to that carbon on either side is going to distinguish the specific type of group it is. So here are the specific types of groups. Okay, so if you have a hydrogen on one side, and then you're just bonded to a chain or a ring or anything else on the other side with a carbon, this is called an aldehyde. If you have any type of carbon group, so you're sandwiched between carbon groups, that is called a ketone. If you have an oxygen, this looks kind of like the ether. Notice the names are similar, ether and ester. So if you have a carbonyl that is next to an ether, so an oxygen sandwiched between carbons, that is called an ester. If you have an OH group, or what we would think of as an alcohol group attached to a carbonyl, that is called a carboxylic acid. And if you have an amine group next to a carbonyl, it has a similar name, amide. So again, an amine group is a nitrogen that can have 3 groups attached to it. Excuse me, 2 groups attached to it. And these could be hydrogens or other carbons. But when you have this amine group next to an amide, it makes it, or next to a carbonyl makes it an amide. Okay, so here are some of the main functional groups that we will be seeing in class. Now, there are a couple other groups that will come up. These are 8 functional groups you'll see less often, but you should still be familiar with them. I definitely want you to be able to name all of these common ones. And again, be familiar with these, so know their names if you see them. These are the nitrile, a carbon triple bonded to an N, an epoxide. Epoxide are rings in nature, and they are a heterocyclic compound, meaning they have something that's not carbon or hydrogen in the ring. It's a 3-membered ring with an oxygen in it. Disulfide, this kind of sounds like what it means. 2 sulfurs, 2 sulfurs bonded together, disulfide. And imine, this one is very uncommon. You actually see this in biology a lot. Imines are formed in catalytic reactions in our enzymes quite often. So when you get into biochemistry, you'll be seeing imines more. You can see this is a nitrogen that's double bound between carbons. An acid chloride. So this is another special type of that carbonyl, except when it has a chlorine group on the side, we call this an acid chloride. Anhydride, this is 2 carbonyls with an oxygen between them. So don't confuse this with an ester, which an ester, remember, looks like this. To be an ester, you have to have another carbon here. But if this carbon is another carbonyl instead, we call that an anhydride. Nitro group, this is often written as NO2. You'll see this as a substituent on rings quite often. And in fact, in organic 2, you will definitely see nitro groups, and you'll be doing reactions with these. And then a sulfide, this looks like the disulfide, except it's just 1 sulfur group between carbons. Now, similar to oxygen, if you remember here, a sulfur with a hydrogen on it is a thiol, but we have a different name for it when it is sandwiched between carbons, which is just a sulfide. Now, generally, if you're having a hard time remembering these are a lot of functional groups. And again, we're going to be going through them, so I suggest that you start on memorizing them now so that they are easily identified throughout the whole of Organic 1 and Organic 2. You can use this quiz. This is just a memorization quiz, a flashcard quiz to help you remember these functional groups. I've linked it on this slide. So for today and for this chapter, chapter 5, we're going to start into the functional groups and focus on two functional groups, which are alcohols and alkyl halides. We will be talking about their naming, their physical properties, and reactions that involve these functional groups. And that will be through the whole of this chapter.